You ready? Let's do it.
Welcome to Peak 22. And today we're counting down our picks for the top 10 space mysteries that scientists can't explain.
But in truth, everything about it is unfamiliar.
For this list, we'll be looking at questions about our wider universe that experts are still investigating. Which of these would you most like answered? Got any theories? Tell us in the comments. Number 10. A possible multiverse. The multiverse is a fun idea to contemplate and makes for some imaginative tales.
The multiverse is a concept about which we know frighteningly little.
But there may also be truth to the concept. The basic idea is that our universe might be one of many, perhaps even an infinite number. The existence of a multiverse has been proposed not only by philosophers, but also physicists and cosmologists.
If we could visit these other universes, we'd find that some might have basic properties of nature so foreign that matter as we know it couldn't exist.
One suggestion is that it explains how our own universe seems to be fine-tuned for conscious life. In an infinite multiverse, it's a sure bet that some of them will have the right initial conditions for the evolution of thinking beings.
It's a bizarrely strange place that scientists are still struggling to imagine. Some think it may even look a bit like this, where each one of these stretched bubbles represents a universe as large and complex as ours.
Many scientists are skeptical of the idea, however, questioning whether it can ever be proven. Maybe our counterparts in a parallel world know the answer.
Sounds about right. But we don't talk about that, do we? No, we don't.
Number 9. Tabby's star. There are an estimated 100 to 400 billion stars in our galaxy, the Milky Way, but one in particular has captured the attention of the scientific community. Known as Tabby's star, it's about 1,470 light-years away in the constellation Cygnus.
It's basically a very weird star. It's a very strange star. What this star showed is something very, very large and very, very dark appeared to be passing between us and the star. It's not a planet because we know that it's not round and it doesn't orbit at a fixed period.
The star mysteriously dims and brightens over time, and the bizarre light fluctuations have baffled scientists.
Often a drop in a star's light levels is a sign that a planet is passing in front of it, but even a planet the size of Jupiter would only block about 1% of the light coming from a star like this.
Several theories have been put forth, but no consensus has been reached. The theories in question range from a cloud of dust orbiting the star to space debris periodically obscuring the light. Some scientists have even speculated that there's an alien megastructure involved.
But if we're already invoking aliens in this explanation, then who's to say they didn't efficiently clean up all this mess for recycling purposes?
Maybe in a few years we'll know the truth. It's hard to study something so far away. Number 8. Jupiter's Great Red Spot. One of Jupiter's distinguishing characteristics is undoubtedly its Great Red Spot. While it looks quite small within the context of the entire planet, the spot is actually enormous. The largest storm in the entire solar system, with wind speeds up to 268 miles per hour. The giant red spot is over 10,000 miles wide, larger than the diameter of Earth.
But scientists studying the spot have noticed that it has been changing over time. The color is deepening, and it's actually shrinking and getting rounder.
Even more fascinating, it's believed that the storm has been raging for at least 3.5 centuries.
On Earth, cyclones die when they hit land, but Jupiter has no land to stop its storms, almost unlimited heat to fuel them, and a rapid rotation.
And yet, we know very little about it. We don't really know what caused it, where it draws its incredible energy, or why it's been going on for so long.
Over the next couple of decades, it's believed the Great Red Spot will shrink in longitude and become more circular. It could stay that way for many years, but if the GRS becomes too elongated, the jet streams could rip the anticyclone apart.
Heck, we don't even know for sure why it's red. Number 7. Missing baryonic matter. Dark energy and dark matter make up 95% of the universe. The remaining 5% consists of visible or baryonic matter.
Dark matter is believed to be an invisible stuff that interacts only through gravity. It comprises 80% of the mass of the universe, or around 25% of its total energy content.
The only thing is, there should be way more baryonic matter around than there actually is. Studies have found a serious discrepancy in the amount of baryonic matter that existed after the Big Bang and the amount that's around today in the observable universe. In fact, over half of this matter just seems to be missing. So what the heck happened to the rest of it? Scientists do have theories, believing that some of this matter exists as difficult to detect hot strands between galaxy pairs or outside dark matter halos, but research continues as measurements improve. Number 6. Alien life.
People just want to think that it's real. They want to think it's real so bad that they're not looking at it completely objectively. If it is real, we gotta know for sure.
It's perhaps the biggest question we all want an answer for. Are we alone in the universe? Mind you, extraterrestrial life could be as simple as a single-celled organism.
Extraterrestrial life. You're right, Jerry. The people are gonna love it.
But the odds do seem to be in favor of the idea of intelligent life out there somewhere, too. Back in 1961, astronomer Frank Drake and his colleagues presented the Drake equation, which attempts to estimate the number of communicative alien civilizations in our galaxy.
The Drake equation, however, is different because there are so many unknowns. It has no right answer. As we learn more about our universe and our place within it, some of the unknowns get better known, and we can estimate an answer a bit better.
Their original estimates were 1,000 to 100 million. Even conservative estimates often land in the thousands. Just imagine how many more could be out there in the wider universe beyond the Milky Way. Number 5. The size of the universe. There are many things we don't know about the universe we inhabit. For example, its shape, although scientists think it's probably flat.
It's way, way bigger. So we're just looking at a little piece, and that's why it looks flat.
More interestingly, we don't know its true size. Ever since the Big Bang 13.8 billion years ago, space has been constantly expanding. In fact, space may expand faster than light can traverse it, meaning that we will never observe parts of the universe beyond certain points. What we do know is the size of the observable universe, comprising objects whose light has had time to reach our solar system.
Not everything you can see in the night sky is actually in our galaxy. It turns out that some of those faint dots are in fact other galaxies. The furthest object you can see actually with the unaided eye is another galaxy called Andromeda.
And it's big. 93 billion light years across. The entire universe may be 250 times bigger than that. Or it may simply stretch into infinity.
So the next time you stand gazing up at the night sky, take a moment to think about the enormity of what is beyond your vision, out in the dark spaces between the stars.
Number 4. The fate of the universe. We have an idea about how the universe began, with the Big Bang. But how will it end? The answer all depends on the universe's density. If the universe is dense enough to counter expansion, the universe will contract in a big crunch.
One theory suggests that our universe will run out of steam and stop expanding. Every star, galaxy, and planet, every atom will start to collapse, ending in a single super-dense pinpoint known as the Big Crunch.
Some believe that afterwards a big bounce will occur, with a new Big Bang emerging from the singularity. In contrast, the Big Rip theorizes that the universe will continue to expand until tearing itself apart.
The Big Rip is one theory. Cruising just above Earth's atmosphere and peering deep into space, the Hubble telescope provides scientists with clues to a less violent, but equally unavoidable, end of the universe.
The leading theory is the Big Freeze, in which continued expansion makes star formation impossible, and the universe exhausts its finite source of energy, cooling to absolute zero.
The expansion wouldn't be able to accelerate anymore, but the universe would keep getting bigger. Clusters of galaxies would separate. The objects within the galaxies, suns, planets, and solar systems, would move away from each other until galaxies dissolved into lonely objects floating separately in the vast space.
Number 3. Dark matter and energy. It's pretty astounding to think that dark matter and dark energy make up most of the universe, and we really don't know anything about them.
The question that's now obsessing astronomers, including Michael Turner, is what dark energy might be.
So, we just don't know what it is. If it is the, like Einstein's cosmological constant, then it's just the energy of nothing. And according to quantum mechanics, nothing is not nothing.
We know that dark matter exists due to certain gravitational effects, and dark energy thanks to the fact that the universe's expansion is accelerating. But what are they? One theory posits that dark energy is a fundamental energy intrinsic to space itself.
Scientists believe it makes up 85% of the matter in the universe, and also controls the remaining 15%. Regular matter, like stars, planets, us. If they're right, dark matter played a critical role in actually building the universe we see today.
Dark matter, on the other hand, may consist of as-yet undiscovered subatomic particles, but really these are just our best guesses. Since dark matter doesn't seem to interact with the electromagnetic field, we have no way of directly observing it.
It's ghost matter. It doesn't glow, it doesn't reflect light, but it adds to the gravitating mass of objects. And if such a clump of material passes through or near our solar system, its gravitational force could have a profound effect.
Number 2. Before the Big Bang.
It's an interesting question, because that's...
I'll just repeat, there's no data to base anything on, right? It's an open question, our present.
There's a strong scientific consensus that our universe began with what we call the Big Bang. 13.8 billion years ago, a singularity, a point of infinite density, expanded, sending forth matter and energy.
So the Big Bang is the observed truth, but there are details that haven't been quite worked out.
There are a lot of things that may have happened. It's just one explanation.
But that just raises more questions. Where did all that matter and energy come from? Since space-time was created with the Big Bang, maybe it doesn't make sense to ask what came before the singularity.
To ask what's before the Big Bang, what's before there is time, is really a meaningless question. And likewise, to ask where the Big Bang occurred is meaningless because there was no space.
But we can ask, why is there something rather than nothing? One possible answer is that the universe is cyclical, moving between big bangs and big crunches.
The stars will collide, the planets will collide, planets will get swallowed by stars.
Even that, though, doesn't really answer all of our questions. Before we continue, be sure to subscribe to our channel and ring the bell to get notified about our latest videos. You have the option to be notified for occasional videos or all of them. If you're on your phone, make sure you go into settings and switch on your notifications. Number 1. Life. When we ask why there's something rather than nothing, it can also be a way of asking, why are we here? How are we here? Why were the initial conditions of the universe such that life could arise? How did atoms come together and start thinking about themselves?
In 1953, one scientist shook the world when he proposed an answer: primordial soup.
Life began on Earth about 4 billion years ago. Some scientists think that asteroids and comets brought the necessities for life to our planet.
The latest theory is that chemicals spewing from underwater volcanic vents solidified and created towers like these, and this produced the conditions needed for the first cells to form.
Believers in panspermia hold that life originated elsewhere and was brought to Earth via the same means.
Another important idea, which is the one that I would subscribe to, is down at the bottom of the oceans in deep-sea hydrothermal vents, where you've got this continuous flow, this continuous energy flow, kind of animating everything from the very beginning.
However, this just defers the question. How does life form? So far, scientists have been unable to create new life from scratch. Although, with time, who knows?
There are many theories. Nobody knows exactly how or where life began.
Did you enjoy this video? Check out these other clips from Peak 22, and be sure to subscribe and ring the bell to be notified about our latest videos.